So good morning everyone. Today we're going to learn the formal language. Okay. So these are the basic difference of a formal language. So what is a formal language? So we know any language is generated by using a specific grammar. Every language has a specific structure of grammar using which the language is generated. So in formal language we have four tuples, that is Vn, sigma, p and s, and we are going to learn the significance of these four tuples. Okay. So first of all, what is Vn? Vn is actually variable. So it is a finite, obviously. The variable number of variables could not be infinite. So it has to be a finite number of variables. And obviously it is also non-empty. So there is no such language which does not have any type of variable. Actually here variable means the character upon which a language is generated. For example, in English language, there is 26 characters. Similarly, here the Vn signifies the variables which is obviously finite and which is non-empty. So Vn is the variables. And in general, the variables are denoted using the capital letters, capital A, capital B, such as. Okay. The second thing is the sigma. So sigma is the terminal. Here sigma is called the terminals. It is also finite and non-empty, and in general sigma signifies the terminal and it is denoted by lowercase a, b, c or 0 and 1. The third condition is the intersection of variable and terminal is always null. That means there is no such character which will denoted both variable and terminal. So we can differentiate a specific character is either variable or terminal, and never the case is that it will be the both variable and terminal. There is no such case. What is s? S is a special variable, and here we can see s is also in uppercase letter, so that means it is a variable and it is a special variable because we start the production from the s. Okay, so s is a special variable and it is also a variable actually, and it is called the start symbol. Now the production. What is production? Production is we can replace the combination of variables or variable of terminals by another variables or terminals. Okay. So whenever there is a production alpha and beta, that means that alpha is replaced by beta. Okay. What is alpha? Alpha is a combination of variable or variable and terminal. But alpha never be only variables. Oh, sorry, never be only terminals. It must include at least a variable. Okay, here where alpha and beta are strings on Vn union sigma. That means the alpha is must contains a variable, at least a variable, has at least one symbol from V. Here it is the signifies that the alpha has at least one symbol from V. The elements of P are called productions or production rules. Okay. So if there is an example of alpha and beta, so it is a production. Acha. So there is another two cases. Reverse substitution is not permitted. For example, if there is a production of alpha to beta, we can replace alpha by beta. But beta can also be replaced by alpha. That is not always possible. If there is a production of from beta to alpha, then only we can replace beta by alpha. Okay. So reverse substitution is not permitted. For example, S is replaced by AB. So here is a production S to AB means S is replaced by AB. Then we can replace S by AB, but we cannot replace AB by S. Using this production, we cannot replace AB by S. If there is a production AB from S, AB to S, then we can only replace this. So reverse substitution is not permitted. And the second thing, no inversion operation is permitted. So if S arrow AB is a production, it is not necessary AB to S is also a production. If there is a production S to AB, so it is not always necessary that AB to S also a production in the production list. So it is not necessary. Okay. Okay. Another thing is that acha, A star. What is A star? A star combines the all the possible strings in the set A. Okay. And what is A plus? A plus denotes A star minus null. That means that A star could be contain null symbol plus A plus does not contain null. Okay. So here null is the empty string. Okay. For here is an example of grammar. Okay. So grammar we know that there is four tuples Vn. So this is Vn. Okay. So this is Vn. Vn means number of variables. Here number of variables is only one. That is S. And the next is sigma. Sigma we know that is terminal, and sigma contains 0 and 1. So terminal is 0 and 1. The third part is the production part. Okay. So there is two production. One from S to 0S1. Okay. So S is the only variable we know, and 0S1 it is a combination of variable and terminals. There is also another production S to 01. Okay. So here in the right hand side there is no variable, only two terminals. And the last symbol is S. Obviously here is only one variable. So we start from the S actually. Okay. Okay. So the production we can use any of the production because both are production are starting from S. Okay. So if we use S to 01, this production will be used, and there is no further production because 0 and 1 both are terminals and there is no variables left. If we use the first production, that is S to 0S1, then this S will be replaced by the two production. We can use any of them. Okay. So if we use the first production n number of times, so this will become 0 to the power n S 1 to the power n. And at the final, we should use the second production to stop the production from there. Okay. So further S will be replaced by 0 1. So in that way, we get, suppose we use four times the production rule. So ultimately this become 0 4 S 1 4, and at last S will be replaced by 0 1. Okay. Okay. Now take another example. Here it is given grammar G. So it has four tuple. The first part is the Vn, that is variable. Next is 0 1, that is terminals. There is two production, both from S. That is there is only one variable S. So all the production is starting from S. Okay, the first production is S to 0S1, and the second production is S to null. We have to find the language generated by this grammar. What will the language it will generate? Okay. So if we use at first the second production, that is S to null, so no further proceedings will be given. So S equal to null we can get. If you use if we use the first production, that is S to 0S1, and this S will be replaced by any of these production. Okay. So we can use the first production n number of times. So it will become 0 to the power n S 1 to the power n. At the final stage, we can replace S by null. So what we'll get? We get 0 to the power n 1 to the power n. So 0 to the power n 1 to the power n by using grammar several number of times. Okay. So what is the language generated? 0 to the power n 1 to the power n, which belongs to language generated, and the value of n is greater than equal to 0. Okay, if the value is n equal to 0, then it will become null. So s equal to null, there is already production there. So the language generated by the grammar is 0 to the power n, 1 to the power n. Okay. We take another example. For g, similar way, g equal to s a, there is a production. Okay, first s is the variable, second a is the terminal. As we know, we denote the terminal in lowercase or 0 1. So in that case, the lowercase a is denoted as a terminal. So s is a capital S is a variable, a is the terminal. Production s to ss, there is only one production, and the starting symbol is obviously the only one variable s. This is the starting variable. So we use s to ss several number of times. Here the catch is we never get the terminal, because in any production in the right hand side there is no terminal. So s is always replaced by another variable. So one variable is replaced by another two variable. In the same way, the length of the variable will be increased, but we never get the terminal. So the language generated by the grammar is null. So no language will be generated, since the only production s to ss in g has no terminal in the right hand side. So then there is no terminal in the right hand side. Okay. We take another example in that case. Here grammar G, there is two variable S and C. Okay? A and B, the two terminals, P and S, and P is defined by the several production. What are the productions? First production is S to ACA. Okay. Second production is C to ACA and C to B. So there is three productions. So we have to find the language generated by this grammar. Okay. So as we know, there is three production. One is S2 ACA, another is C2 ACA, and another is C2 B. So what, from where we will start? We find the starting symbol. Here the starting symbol is S. Okay. So production starts from the starting symbol. So S2 ACA. So S2 ACA is the first production. This C would be replaced by ACA or by B. If we use the B, so the ultimate terminals we get, that is ABA. So ABA is obviously a language generated by the grammar. And in here, if we not use the second production, we can use the production S to ACA. And this production will be used several number of times. But in the final, we use C to B, because the first production always generate a variable on the right hand side. Okay. So to end the production, we have to use the production C to B. So you use several number of times. For example, n number of times. So we get AN, CAN, and in the final, this C is replaced by B. Okay. So we get A to the power n, B, A to the power n. So what is the language generated by the grammar at final? Finally, we get AN, B, AN, which is belongs to LG. And here, n value of n is greater than equal to 1. Here, we note that